Hello, hi everyone. Welcome to Double E Academy. Myself Vinay BK. And without wasting time, so in this video, I am going to explain you about source transformation and shifting methods with the help of one numeric problem. Okay, so we'll use one numerical problem and you just try to apply that to the other problems also. It may help you. Okay. So just observe here they are given using source transformation and shifting. Find voltage across 2 ohm resistor. Voltage across 2 ohm. You just observe here is a 2 ohm resistor. Okay. So voltage across this you need to find. And this is a circuit diagram. They are not given any node namings. I am just giving you for your reference as A, B, C, D, E, F. So in this problem, we can do both. That is current shifting as well as voltage shifting. So you can see the current source here, A, F, E. Current is flowing from E to F, F to A. So this you can do indirectly. Again, E to B, B to A also you can do. Similarly, voltage source can see C, D. You can shift this voltage source to C to B once, C to A once like this. For example, just see now. So instead of seeing this current source, I can shift the current source like this. So E to B directly with the upper arrow mark of same current 2 amperes, then B to A with a opposite arrow mark towards A. Then only current is flowing from the same current 2 amperes. Current is flowing from E to B, then B to A. At B, current becomes 0. 2 amps is entering, 2 amps is leaving, as you all know KCL. So this is how we can shift the current source. Similarly, you can shift the voltage source also. So you can see the voltage source. At this voltage source, you can shift at C to B branch and also C to A branch like this. Then this becomes short circuit. This 5 ohm becomes short circuit. Then you are shifting the polarity also like this. See now the polarity minus and plus. Similarly here also see the polarity like this. You are shifting minus and plus. 5 volts it becomes short. So this is what the steps to shift the voltage and current. So let us see step by step. So what is the first step? Shifting of current. So first step what I will do? Current shifting. C bar N. Current shifting. The same circuit. So what I will do? So I will write A to B there is a 5 ohm resistor and B to E there is a 2 ohm resistor. And this voltage you need to find voltage across 2 ohm. So I am shifting the current from E to B, then B to A instead of E F A. So that current is flowing like this upward direction of 2 amperes towards B, then B to A. The arrow is from B to A. The same 2 amperes is flowing. Then rest of the circuit will be same. So I will write rest of the circuit same, that is B to C there is a 4 ohm resistor and there is a voltage source C to D of 5 volts plus minus 5 volts. Then again here to see there is a resistor of 3 ohm like this, 3 ohm. So next what I will do? So I will shift the voltage source next. Later we'll do calculation and all. Okay. So next what? The same circuit diagram. I am shifting this 5 volts at C to B branch and C to A branch. So it becomes circuit becomes like this now. The same current 5 ohm, sorry, 5 ohm resistor, across that there is a current source of 2 amperes like this, and again 2 ohm resistor, there will be current source again of upper arrow, that is 2 amperes A, B, E. So now I'm shifting the voltage source. So for that voltage source, see now the arrow minus to plus, here also minus to plus, shifting of voltage with respect to resistor. So that minus plus this direction, and the original voltage source becomes short circuit. So there is a 5 volts, 4 ohm, and again A to C there is a 3 ohm resistor, shifting of voltage source again here minus plus of 5 volts. This will be 3 ohm resistor C D. Okay, so now we'll do, so shifting is finished now. So now we can do what? Source transformation. So what, using the source transformation, you should not touch this 2 ohm resistor, because you need to find voltage across 2 ohm only. So that what can able to do, we can simplify rest of the branches. So that what I will do, first I'll convert all the current source into voltage source by leaving BE branch. Okay, so now this 5 ohm 2 amperes, this, so it becomes what, series of practical voltage source. So practical voltage source I will write as it is. There will be voltage source, direction is right to left, right to left it is flowing, so that that is nothing but minus to positive. I will write minus plus V is given by I into R, whereas I is 2 amperes, that is nothing but 2 into 5, so it becomes 10 volts, connected in series with what, 5 ohm resistor, like this. So I will write this B branch, so this is A, it is as it is, I will write 2 ohm resistor, and there is a current source with a upper arrow mark at E, 2 amperes. Okay, so I'll write this as it is, 4 ohm 5 volts plus minus 5 volts 4 ohm, and at C to D, D to E will be shorted, C D. Now this is also as it is, 3 ohm and 5 volts, 3 ohm 5 volts. So now it is very simple and very easy to understand. Now you can see these voltage sources. So it is nothing but there will be plus minus 10 volts is in series with 5 ohm and 3 ohm, and again plus minus 5 volts. This becomes A to C branch, A to C. So you can observe 5 3 are in series, so that you can get equivalent resistance 8 ohm, and voltage you can see. So there will be left, right to left arrow 10 volts, and also, sorry, okay, or shifting this. So this is nothing but what, this will be minus, this will be plus. Okay, sorry for the, sorry for this. I'll erase this now. Okay, so I hope you got to know. So I'll rewrite the circuit once again. You can see. So this circuit I will rewrite as like this. Later we can do step by step simplification. Then only can easily understand. So this circuit I will rewrite as it is, as like this. So B is here, B to C, I'll write as it is, B to C, there will be 4 ohm resistor and 5 volts voltage source plus minus 4 ohm B, and there will be C. And also B to E, there is a 2 ohm resistor, and rest will be shorted here. C, C, D, E. There will be current source as it is as per the problem. So 2 amperes, 2 ohms, 2 ohms. So here, how can you write now? So from B, so I will rewrite like this: 5 ohm. So I am just tracing this. The voltage source is here. Voltage source you can see now. It becomes minus plus right here minus plus, then again 3 ohm resistor, then again plus minus of 5 volts, 5 volts, 10 volts, 3 ohm, 5 ohm. You can see the arrow mark here is a left to right, and here there will be right to left. So that left to right arrow mark voltage source is having highest magnitude, so that you can consider that magnitude only, so that there will be subtraction of voltage source. I'll rewrite again now. So you can get 5 plus 3, 8 ohm, 10 minus 5, 5 volts. Okay, so that rewrite here. So first I will write rest of the equipment, that is the rest of the branches, 4 ohm and 5 volts plus minus. Then there will be 2 ohm resistor. So I'll just make closed loop along with the current source of upper direction of 2 amperes, 2 ohm, 4 ohm, 5 volts. So again, now I'll write the simplified here. So 5 plus 3 is 10. Sorry, 5 plus 3 is 8. So that I will write here 8 ohm and 10 minus 5 is 5. And the source which is having left or right arrow mark will be having highest magnitude. So that I will write that is minus 2 plus. This is 5 volts. This is 8 ohm. So now we can easily simplify. So what I will do, so I'll convert these voltage sources, B to C branches voltage sources into current sources. Then I'll get two equivalent current sources. Then I'll get current flows to 2 ohm. Then I can get voltage across 2 ohm. Very simple. So now you can observe. So there will be 8 ohm resistor, and the direction is left to right. So that current direction will be left to right, 8 ohm, and I is given by V by R, whereas V is 5. I'll write it here, V by R. V is 5 and R is 8. 8 by 5 is nothing but 0.625, I guess. 5 by 8. We check once. 5 by 8 is 0.625 amperes. I'll write it here. Current is 0.625 amperes. And one more branch. I'll write it here. 4 ohm resistor. 4 ohm resistor connected across again one current source. The direction you can see here, minus 2 plus, right to left. So the direction is right to left. So this current is given by I is given by again V by R, whereas V is 5 volts, R is 4 volts. So that 5 by 4 is nothing but 1.25 amperes. 1.25 amperes. So now what I will do, I'll rewrite the circuit, 4 ohm, then we'll be having one more resistor. Don't forget that. That is 2 ohm resistor connected here. There is a current source with upper direction of 2 amperes. So now you remember one thing, whenever you are observing the circuit diagram, that line represents wire. With the help of that, you can easily what rewrite the circuit diagram. So before that, what I will do, so I'll get equivalent resistor and equivalent current source. You can see 1.25 amperes is having highest magnitude, so that we should write that direction only. So total current is given by at B to C, IBC. So 1.25 minus 0.625. I'll check it. 1.25 minus 0.625. You can get 0.625. 0.625 amperes. So I will write here now 0.625, and direction is, remember, 1.25 is having left, right to left direction. So that I'll consider that magnitude 0.625. And equivalent resistor. Equivalent resistor is nothing but 4 is parallel to 8 ohm. 4 is parallel to 8 is nothing but 4 into 8 divided by 4 plus 8. You can get 2.667. You get 2.667 is a resistor. 2.667 ohm. So again, I'll connect this to resistor 2 ohm. I'll close the circuit, and there will be current source of upper arrow mark of 2 amperes and 2 ohm. So now you can see that line represents wire, so that you can easily rewrite this circuit. So I'll shift this branch in a vertical direction. So you're shifting this branch in a vertical direction. So instead of writing horizontal, I'll just shift to the vertical direction. So the circuit becomes like this: 2 ohm and 2 amperes with upward direction. Okay. Then I'm shifting this branch, horizontal branches, into vertical. So it becomes like this. Again, the arrow mark of current will be upward direction. I'm shifting this to here, like, so that the arrow mark will be upward direction. That is nothing but 0.625 amperes. Yes, 2 amperes, and resistor is 2.667 ohm. 2.667 ohm. So both the currents are in upward direction, so that resultant current will be addition of the current. So you can get what? So 2 plus, so you can get 2 plus 0.625. 2 plus 0.625, same direction, that is upward, so that upward direction 2.625 amperes. I'll write as it is. Two branch of resistor, one is 2 ohm, other one is 2.667 ohm. 7 ohm, 2 ohm. So they ask you to find voltage across this 2 ohm resistor. So that voltage across 2 ohm is given by 2 into current flows to this. I'll consider that as I is flowing here, 2 into I. So if you get the value of current, then you can get the value of voltage across 2. So that current I is given by applying voltage divide rule. So applying current divide rule. Sorry for that. By applying current divide rule in a parallel circuit, you get what? Branch current. So this branch current I is given by total current is nothing but 2.625 is the total current into opposite resistor is nothing but 2.667 divided by sum of total resistor, that is 2 plus 2.667. So just take this 2.625 into 2.667, 2.625 into 2.667 divided by 2 plus 2.667. So you can get 1.5. So current flows through that will be 1.5 amperes. I. So now we can get the value of voltage. V is given by 2 into I. So V at 2 ohm equals to 2 into current flow. So 2 ohm is 1.5. So that voltage across 2 ohm becomes 3 volts. And this is the solution with the help of source transformation and source shifting. So if you're having any doubts regarding this problem, you can do a comment in the box. And thanks for watching. So it may very helpful to the circuit analysis, those who are studying circuit analysis subject, so that make use of this and try to share maths. Thank you one and all for watching this video. Thank you.